What's up, everybody? Welcome to the channel. UziNets, that's me. I'm Uzi, and today I'm starting my 10-part series on computer networking. By the end of this series, you'll know most of the things you need to know about the nuances surrounding computer networking and network engineering. And today we're starting off with the basics with the OSI and TCP IP models. I'm not going to waste any more time, so let's get into it. So we're going to start off with two basic types of networks. Right here we have local area networks and we have wide area networks. A local area network is essentially what you have at your house, where you have a router, an Ethernet cable, and you have a bunch of devices connected to it. That's a LAN. A WAN, a wide area network, is a bunch of LANs connected together. That creates a WAN. And the largest wide area network would be the internet because it connects millions of LANs across the entire earth. And these wide area networks are connected through things called data centers. Now, these data centers are giant facilities. Right here on the bottom left is Meta's biggest data facility. It's in Iowa, and to the right of that is the inside of a data center. You just have aisles and aisles of computer hardware. So these centers house thousands of servers where they host websites, applications, cloud data, etc. And there's thousands across not only the US but the entire world. And they're connected primarily through high-speed fiber optic cables underground and through water, essentially creating a global network. So this global network we have today has really just been created by connecting physical fiber optic cables throughout the entire world, either underground or underwater. What you have here is a cable ship. Through this diagram, you'll see a cable ship has this functionality where it'll just plow a fiber optic cable through the bed of the ocean floor. And this has all been done in the last 25 to 30 years, which is pretty amazing to see how far we've come in such a short amount of time. So now that we've went over what a network is, let's talk about how data moves through a network. And for that we have the OSI model. This is a 7-layer framework, not a particular protocol used in the industry. It's more of a framework for teaching and troubleshooting. So starting from the bottom up, the OSI model has 7 layers. We have physical, data link, network, transport, session, presentation, and application. Each layer has a specific responsibility and data passes through each layer as it's sent and received. So with regard to networking, I would say the layers that matter the most would be layers 1 through 4. So physical, data link, network, and transport. The physical layer is exactly what it sounds like. The physical cables, whether it be fiber optics, Ethernet, that physically connect our networks. The data link layer is more about device-to-device communication on your local network. Each of your devices, your iPhone, your router, has a MAC address. And a MAC address is essentially used like a serial number to make sure that the correct data gets to your device. The network layer is the next layer, and it's a very important layer. This is all about IP addresses and routing. So routers use IP addresses, which are on all our devices, same as MAC addresses, iPhones, routers, all have IPs, and they decide where our data should go across networks. So essentially, this is how your data travels from your home local area network all across the world. And the next layer I will talk about is the transport layer. The transport layer decides how your data is delivered. There's two main types, TCP and UDP. TCP is Transmission Control Protocol. It's very reliable. It makes sure data arrives in order without errors and without missing pieces. If something's lost, TCP resends it. So for example, websites, emails, file downloads all use TCP. Then you have UDP, User Datagram Protocol. It's fast but not reliable. This is more, say, like streaming games and whatnot, and the stream cancels out, but it doesn't completely close, because it's better to drop a frame than freeze the entire stream. Now these last 3 layers, session, presentation, and application, these layers, they gear more towards software engineering. They handle things like session managing, session creation, formatting data, HTTP requests, things like that. Network guys usually focus on layers 1 through 4. And in terms of the OSI model and why it's not fully practical, no device is actually going to tell you I'm operating on OSI layer 5 or layer 3. It's just a teaching and troubleshooting tool, like I said before. In practice, in the real industry, people use this model, the TCP IP model. This model is really a simplified version of the OSI model. So you have the network access layer, which is equivalent to layers 1 and 2 from the OSI. You have the internet layer, which is really the network layer from the OSI. You have the transport layer, which is the same as the transport layer, and the application layer, which covers layers 5, 6, and 7 from the OSI model. This model reflects how the internet really works, so it's more applicable in the real world. So to give a real life example, say you want to write a letter and deliver it to somebody. First step is you write the letter. That letter you wrote is the application layer. It has all the data, and now you want to send it. So next you decide how important is this letter. That's the transport layer. If it's very important and speed matters, you want to use TCP. If speed doesn't matter, you want to use UDP. The next layer, the internet layer, or the network layer, is where you put the destination address on the envelope. This is similar to the IP address that tells the postal system where the letter needs to go. And finally, you have the network access layer, which is, remember, layers 1 and 2 in the OSI model, the data link layer and the physical layer. So inside your local post office, workers use internal routing labels to get the letter to the correct truck. That's like a MAC address in the data link layer. And the physical layer, of course, easy. It's just the trucks, planes, and roads that physically move the letter, similar to the cables that help networks get across and connect. So that's going to do it for this video. I hope you understand the OSI and TCP IP models. I know I didn't cover all the basics, but I will throughout this 10-part series. This is just episode 1. Stay tuned for the next episode. Comment, like, share, subscribe, follow for more. Thank you guys. I'm out. Peace.